Good afternoon, ladies and gentlemen. Welcome back to lesson 3, part 2. And again, if you're watching this out of order, that's okay. The previous video, I think, walks you through the strategies of how to determine the equation of a sinusoidal function given its graph. I'm actually going to look at activity 1 and activity 2 from this package, and hopefully you'll be okay with these examples. Here we go. Activity 1 says, first study the effects of the various parameters a, b, and c on the graph of y equals a sine b, x minus c plus d. And if you already watched the previous video, I've already talked about what a, b, c, and d relate. Notice, a stands for the vertical stretch, b stands for the horizontal stretch or compression, c stands for the horizontal shift, and d stands for the vertical shift. However, a lot of you actually understand that a kind of relates to amplitude. B relates to the period, although we have to use a formula. So I'll put a star here. The C is related to the phase shift, and the D is related to the equation of the axis, or the midline. So step 1, this is going to be easy. You can ignore the Graphmatica and the grid range, and you can just do this yourself, or you can definitely use resources called Desmos, or you can use Geogebra. I'm not spelling it as well, but let's see how it goes. And they're both online, they're free, and they're really, really good. And so what you're supposed to be getting out of this, though I encourage you follow along and have the technology if you have to pause the video and just confirm it for yourself. So for the first thing, graph and sketch the following functions using the same set of axes. So we're going to graph y equals sine x and then y equals 2 sine x. So I'm just sketching. So I'll use black to always represent y equals sine x. Notice the maximum is at 1 and the minimum is at -1. So in blue, if I wanted to graph this y equals 2 sine x, I think a lot of you actually understand that. It's going to look something like this. And what you're supposed to get out of this is that the amplitude got stretched. How about 0.5? Let's use this fainter color. Well, I think a lot of you understand. Between 1 and 0 is half. And that'd be y equals 0.5 sine x. So that's all fine and dandy. How about step 2? Graph and sketch the following. This time I'm only going to do one of them. These are just sketches, right? It'd actually be better if we actually had a graph paper, but I don't have it, and that's okay. Our goal is just to make sure you understand this. So y equals sine x, that's the one in black, right? In red, they're asking us y equals -2 sine x. So first of all, a lot of you already know that the 2 is probably going to be congruent to this graph. But the negative, when a is less than 0, it means it reflects across the x-axis. So we still have to have that -2 down here. We still have to have the 2 pop up here. But I think some of you actually understand what we're doing. And this is y equals -2 sine x. But notice still what I'm going to say. What's the amplitude? The amplitude is still 2. The amplitude is always positive. Describe the effect of a on the amplitude of the sine of the function. Well, the vertical stretch, or the a value, is the same thing as the absolute value of the amplitude. That's the answer for step 3. However, part B, notice they're asking you to do the d value. And again, I'm only going to do 2 of these. I think we were using orange, but that's okay. So this time I'm going to graph y equals sine 2x in black. And notice what I'm going to do here. That was not good. Let's retry that. Much better. And again, it should be congruent to the red one and the blue one. It actually should be the blue one, right? So what we want to do, and I think I was using orange, y equals 2 sine x plus 3. So a lot already know that this plus 3 is the d value. So what's the equation of the axis going to be? I didn't give myself enough room. Well, 3. So this is already like my 4th take of doing the videos, and I'm already tired. I am probably not going to redo it, but let's just make sure we're okay. So let's just smooth this down. So that's my graph, y equals 2 sine x. That's 2 there, negative 2. So plus 3 would be maybe here, but it still has the same amplitude as the 2, right? So hopefully you guys can see that. So what most of my students would do, I'm just drawing the equation of the axis, or the midline, at y equals 3. And notice where I'm going to start. I'm going to start there, but it has to have an amplitude of 2. I didn't draw that right either. Holy cow, what's wrong with me? Hopefully a lot of you are correcting with my mistakes here. That's what you get for not having enough sleep. Oh well, make the video longer. Feel free to pass through this. That's 3. So we have to go to 3 to 5. Go down there, and then 3 down to 1. So it should be congruent to the black one, but this has obviously been shifted up. Describe the effect of D in the graph. Well, D is the same thing as the equation of the axis, or the midline. And it shifts up and down. I already know that. That's why amplitude, the A, and the equation of the axis, those two tend to be the easiest ones. How about B? Effect of B in the period of the sine graph, y equals sine bx. So in this case, what we're going to do is 2 of them. And again in black, that's y equals sine x. That's my sketch, just to make sure it was okay. And we're going to use radians here, if that's all right. So 0 to 2 pi. The amplitudes, the maximum don't really matter, but let's do some things properly. So that was y equals sine x. So this is now y equals y equals sine 2x. So the b value is 2. So what's going to happen to the period? Well, from the previous video, a lot of you realize there's a relationship between the b and the p. Well, the converse is the same. The period is also related to 360 degrees divided by that b value. Or, since we're using radians, 2 pi divided by that b value. In this example, the b value is 2. So doing some math, the period is going to be equal to 2 pi divided by 2. And so what is that value of the period when the 2's divide out? The period is going to be pi. So a lot of you already understand that's going to be pi, and I need to fit that sinusoidal function there. So the only way we can get that is if we squish it through. Now maybe I kind of drew that incorrectly, so let me just draw that again. Maybe this will erase. Yeah. Let's draw the black one again. And let's draw the red one again. Notice that this graph is supposed to be still the same amplitude. What's wrong with me? It should be the same amplitude as the first one. Let's try that again. And I think a lot of you understand that since the b value is it's greater than 1, it's a horizontal compression. Horizontal compression. A lot of you don't know what I'm doing. So that's y equals sine x. And the second example that we have, the b value is 0.5. So what's the period? 2 pi divided by 0.5 is 4 pi. So we need to graph this. We need to graph this guy. So that period has to be 4 pi. Still have the same amplitude. So that's pi, 2 pi, 3 pi, 4 pi. Let's see how it looks. And again, it should have the same maximum, same minimum. And that's y equals sine 0.5x. So describe the effect of b on the period of the sine function. Find the period of the sine function in terms of b. So a lot of you already understand the relationship already. P is equal to 360 degrees over b, or 2 pi over p, or vice versa. B value is equal to 360 degrees divided by p, or 2 pi over b. And a lot of you already know what I'm doing, rearranging that relationship. The final thing that we're going to do before we get to the real question, understanding the phase shift, the c value. So this one, I only have to do one example again, because I think a lot of you already understand this already. This is the graph of y equals sine x. That's 0, that's pi, that's 2 pi there, that's pi over 2, and that's 3 pi over 2. So for our question here, and I think we were using purple, let's graph this one, y equals sine x plus pi over 2. A lot of you already understand this, that's the c value. And so this is probably, it's probably a shift left of pi over 2 units. So we're going to take this black sine graph and shift it all the way left. It still has to have the amplitude of 1. Still has to have the period of 2 pi. Still has to have the equation of the axis of 0. The only thing about the phase shift is left pi over 2, or negative pi over 2, because it's plus. So that's where we're going to start. But everything else is the same. So it's going to end there, and it's going to end there, really. So it should look something like that. And you can see it, that's y equals sine x plus pi over 2. I already know the kind of connection between this question right here. This is also the same thing as y equals cos x. Why? Because it started at a maximum. So a lot of you already know to describe the effects of c on the phase shift. Shift left, shift right. So I'm going to just do the very first question, activity 2a, and use transformation to describe the graphs of y equals 3 sine 2x minus pi over 4 plus 2. So describe what's happening. Well, you're combining basically what we've taught you already, and let's see if you can follow along. Given an equation, do you think you could tell me the amplitude, the equation of the axis, which is the d, the period, which is p, or the phase shift, which is s? Many of you guys students can do this. They can definitely get the amplitude. They can definitely get the equation of the axis, and the phase shift is shifting right pi over 4. The only thing is to find the period. But I think a lot of you understand that the b value and the period are related, but we have to do some math. So since we're dealing with radians, we have to do some math. 2 pi divided by that b value, and you got it, it's pi. So describe what's happening. In English, it's going to be vertical stretch by a factor of 3. It's going to have a horizontal compression by a factor of a half. It's going to shift right pi over 4 units. And it's going to shift up 2 units. But I think it actually helps to describe visually what's happening. So let's just do this in stages. And in black, y equals sine x. And that's the y equals 3 sine x. I'll try to do this in stages so you can see it. So that's the first graph. That's the same as this blue one. Okay, so I'm just trying to make sure we're okay so I can fit. What did I use the colors again? Shoot. I think I used red. So the red is going to look something like that. And the red is y equals 3 sine 2x. And then I think we used purple. To shift left pi over 4 units. So let's just draw that red graph again so you can see the reference. And again, these two are the same. So the purple is going to be shifting right. So that was pi. That's going to be there. And this is the y equals 3 sine 2 x minus pi over 4. My apologies for my handwriting. And then we're back down here. So that's the graph there. That's the same. And we're going to shift it up too, to the orange. Oops, that's not right. That's 3, so that should be something like maybe down there. And this graph is the y equals 3 sine 2 x minus pi over 4 plus 2. So I kind of did it in stages, and hopefully you saw the animations. Now there is actually an alternate way of just getting the answer, but we'll do that when we get there. Hope you enjoyed it. Enjoy your day, and I apologize if there was any high-pitched sounds.